and W and Q. Finally, the process is represented on the PV or TS diagrams. Okay, we need to do this. And after these 4 steps, we can get all results we are interested in. Okay. So maybe it is a little hard for us to understand this. I think we can get some examples. Okay.
Yes, of course.
Okay, this is some equations for calculating the, for example, I think we just need to remember it. There are U, there are H, and the DS, the expansion work, and the technical work, or the Q. Okay. This is the first law, is the first operation. This is the second operation. Okay. This is for the closed system, and here is for the open system. Somebody are trying to okay, I think it's good. It's good for you. I think. Okay, now I think some simple examples. Okay. Now, for the first process is a colic process. We know with process equation is V is equal to a constant. Or dV is equal to 0. Okay, this is our first step. We will make that is the process equation. And then find out the relationship between each final state parameters. How to calculate, how to find out it. Okay? This is the state function. And here is the process equation. And then this one. Okay, this one is the relationship. So I think we all get it now. Okay? Next, step 3. Let's try to calculate the W. How to calculate the W? Because dV is equal to 0. So we know the expansion work is equal to 0. Okay?
Yeah.
But if we say for isocolic process or the constant volume process, the system cannot do work to the surrounding. Do you think it is right or wrong? Because the system cannot do expansion work to the surrounding, but it can do what work?
Shaft.
Technical.
Technical.
It can do technical work to the surrounding. Yeah. So we should remember this. For a constant volume process, the expansion work is equal to 0, but the technical work is not. It's not equal to 0. Okay.
Yeah.
And then we can try to calculate the Q. I think you know this equation. Also, we can use this one. Yeah. We can use this one. We know okay, Q is equal to delta U. Okay. So we can say for a constant volume processor, the system absorbs all the heat absorbed by the system. We use it to increase its internal energy. Yes?
Yeah.
Okay. And then, because the U, we calculate it now, we get the U now, and we, in the next, we need to calculate the delta U. Do you know this one? Delta U, du is equal to Cv dt. Of course. Also, delta H can be calculated by this equation. And here is the equation used to calculate the change of HP. Okay? Maybe.
So these are only for isocoric.
Yeah. All this is only for the isocoric process. Or we call it the constant volume process. Okay? All this is only for this one. Special, typical. Maybe we can say this is for the typical. Here. Typical thermal process. This is the first typical thermal process, isochronic process.
But Laoshi, what's an isochoric process?
What is isochronic process?
Yes.
It's a constant volume.
It's a constant volume.
Constant volume, yes. Here is a volume, we are not change. Or we can say dV. dV is equal to 0. dV is equal to 0, okay. Here, another question. Why here? Because we know this process is like isochronic process, a constant volume process. So why we can use the Cp here?
Because Cp equals Cv plus R.
You just remember, I told this again and again. Just remember one thing. H is a state parameter. Okay, just remember it. Okay.
Yeah.
It's a state parameter.
State parameter.
So the change of a state parameter is early related with its initial and final position. I think, for example, maybe we can talk it. For example, here is a here. Okay.
Yeah.
It's a here. As we know, the height of the here is a state parameter. Somebody, because A is come here, and then we made the height of the
state parameter
here, and some other guys here. This is A, and this one is B, and the B comes from here, and she made the height of the here also. Maybe here is HA, and this one is HB. We all know HA is equal to HB. Yeah.
Yeah.
Right.
So this is what is the state parameter. Okay. Okay. So next, we need to draw a figure. In our class, firstly, you should learn to calculate some. You should learn how to calculate the Q or the W. Okay. This is one end, and another. You should learn how to draw some kind of picture, but not so simple. This is kind of simple, but we may be in the future we may need to draw different pictures to one figure. For example, this is a constant volume. Okay, this is the figure. In the future, we are asking you to draw the process, constant volume, constant pressure, the constant temperature, and adiabatic to one figure.
Wow. Okay.
Okay, I think that we are really hard. Not so simple, because now it's quite simple.
Simple, yeah.
Because the volume
It's constant.
simple, yes. And for the TS figure, it's like this one, okay. This is quite simple. But here, a question, okay. This line is represent all this line. Maybe we can say it is a constant volume line. Okay. So I have a question. Which one, the volume, which one is the biggest one?
The biggest volume, or
This is the volume. VA, VB, and VC. Which one is the biggest one?
the biggest volume.
Which one?
No.
This
All
one
of them
is
all
VA,
of them are the
VB,
same.
or VC?
Yeah, they are the same.
I think it is a bit hard for you now.
No,
But
VA.
after our class, I hope you can
If you could see.
I see VA.
VA. I don't know, maybe it's not right. Let's try.
Are you guessing?
Okay?
No guess.
Just guess it. I know. Now, do you know what is this line? This line is a constant temperature. And let's try to calculate the SC minus SB. Do you know how to calculate the SC minus SB? I think you.
Yeah.
And now, if we put this equation here, and now then we have found CV here, this part is equal to 0, because T1 is equal to T2. here is TC is equal to TB. Yeah. So it's equal to 0, and then it's like this. Yeah. And now, what?
How about the R? So you will find the result of
No, I think this is not right. No. Here is
It's a plus.
Here is wrong. Yes, maybe here. Maybe this one. I'm not sure. But this is wrong. Okay. This is wrong because this part is equal to only this part left. Yes, only this part is left, and then here the R. Not CV, not CV. Okay. And now we know from this figure, SC is greater than SB. So we know SC minus SB is greater than 0. Yeah? Because this part is greater than 0, we need to, this part is greater than 0 also. So we need to VC greater than VB. So we have found VC is the biggest one. Okay, so maybe okay. Here is maybe you can say it's a conclusion, but I don't think you need to remember this conclusion. I hope you can try to prove it. You can, okay? Try to prove it. So this is in the TS figure. When the isochronic line moves horizontally to the right, and the specific volume increases. Okay. Okay. If we don't want to prove it, you can remember it. It's okay, I think. But I hope you can. You don't need to remember this conclusion. You can try to prove this. Okay. And here is another one. Last case, maybe it's another typical thermal process. Isobaric process. This is a constant pressure process. And we also know is a process equation is P is equal to a constant one. Okay? And the relationship we also can get it because we know PV is equal to RT, the state function, and now we get this one. The relationship between PVT. Okay? And now let's do some calculations. Here, for isobaric process, do you think the system can do technical work to the surrounding?
Isobaric. Yes.
Yes or no? Try to think about it.
Pressure.
Think
Constant.
No,
I think.
No, think. You need to
Be sure.
prove it.
Think, not
Okay.
forget.
So you shouldn't, I think you should know how to calculate, for example, the technical work. You should know this equation. I hope you need to remember. Do you remember I tell you in our final examination, you can take a paper.
Yeah.
Okay.
Yeah.
So if you cannot remember it, just try to write it down on paper. Okay.
Yeah.
Here, WT is equal to this. But I have one question. Do we say this is a paper?
What?
I say you need to take a paper. Is it right or not?
Right.
Because we know paper is also means minus square. When I say I write 2 papers 1 year or 3 papers,
You need to take a sheet of paper.
a sheet of paper. Okay, thank you. It's just a little for you. A sheet of paper. Okay, thank you. Okay, here is the box for isobaric process. You know, the technical work is equal to 0, but the expansion work is not. It's equal to this one. Okay, and then the Q, we also can use this one. Here you don't care. Please, you don't need to know what is this one. You just remember one. This one, Q is equal to C.
MP.
You don't care. You don't care.
Oh.
C, P or CV, and then times T2 minus T1. Okay. And here, This is the first law. It's equation. Okay, in the open system. Yeah, in open system. And now we can get the Q is equal to delta H. So we know in a constant operation process, the system, or we can say the heat absorbed by the system, will all used to increase its SMP. Yeah. Okay. Maybe it is a little hard for you, but for me, I try to translate this equation to an English word.
Yeah.
I trust you can get it. Okay.
Yeah.
I hope you can get it.
We will.
Okay. And this is the equation used for calculating the delta U, delta H, and for the BS. Okay. Figures. Now, here is a TV figure. This is the cost of operation. Cost of operation. And this is for the TS is a constant pressure process also.
Yes, Lashi.
Yeah. This is kind of simple. Yes.
Yeah.
Okay. Last question. This is some constant pressure volume. 9. Constant pressure line. Okay. So one question is, which one is the biggest one? PA or PC?
Lashi,
I don't trust you.
PA.
Why? Can you give me a reason?
Because when temperature is becoming more horizontally constant, pressure reduces because of PV equals nRT.
PA is the biggest one?
Yes.
But the process.
What do you mean? I
constant
think you
process.
give me maybe a better, good explanation. You say if
When
we
temperature is horizontally becoming
This
constant, yes.
we
Pressure.
set a constant on temperature line,
Yes,
okay?
yes, pressure reduces. So PC is reducing from PA to PB to B to PC, which means PA
Which one is
higher.
reduces?
It reduces from PA to PB to PC. So PA is higher and PC is smaller.
Okay, I think you are, maybe you got it, but I didn't get you, I didn't get you now. But let's
Okay, Lashi, what is your explanation about it?
because I try to learn from you. So I think maybe I need to think about it carefully when I back home. But now, just listen to me, okay? This one is the same.
Yeah,
It's
it's the same.
And then we can. You are right. I think I remember you are right. You are right.
Yes,
PA
like,
is the biggest one.
yeah.
Okay, but I hope we can, in the future, we can just take a look at it, and then we can get the results. We don't need to
Think
prove
about
this.
yeah.
So, maybe we can discuss it, okay, a few minutes later. So, just remember, for the isobaric line, when it moves horizontally to the left,
Yeah.
and then the pressure increases, okay?
Yeah.
Here rather. Okay. I draw two lines here. One is maybe one is a constant volume, and the other is a constant pressure. So now, my question is, which line is the isochronic line?
B.
B.
Is of course.
Constant volume. No, I don't think it is B. Okay.
Maybe.
No. We can try to prove it. Okay.
Okay.
Okay. Because mechanics is quite strictly. All conclusion can be proved strictly. Because sometimes we don't want to, but all conclusion can be proved.
Yeah.
For the isochronic, we can try to calculate the slope of the curve. Yes? Do you think this is, do you agree with this one? This is the slope of the curve from this equation, okay?
Yeah.
For this one, as a public process, we can also calculate the slope of the curve, yes? Now, which slope is bigger? Which one? Because we know Cp is greater than Cv.
Yeah.
So now we know this slope is greater than this one.
Yeah.
So in this figure, which one is the isochronic line? A.
A.
So on a TS figure, the isochronic line is
Deeper
deeper
than
than the
isobaric line.
isobaric line. Okay, just try to remember this one. This is quite important. Sometimes I think it is a little hard for us to remember which one is deeper. Yes. So I think I can maybe try to remember it like this. Okay. We can draw the constant volume line and the constant. Here we can draw it on the PV finger first. We can draw it. Okay.
Yeah.
For this one, it's a constant pressure line. Yes.
Yeah.
And for this one, it's a constant volume line.
Volume line.
Yes.
Yeah.
Okay. And then at the same time, we can draw it on the TS figure. We can draw two lines. It is a little hard for us to remember which one is the constant volume, which one is the constant pressure. Just try to, in this figure, on this figure, which line is deeper?
V.
Do you think V is deeper, it's much more deeper than this P, yes?
Yes.
So, this one is deeper, yes? So this is V,
And this is P.
P.
Fantastic.
So I think, because we all, I think for you to draw this finger is quite simple, yes? But maybe it is a little harder for us to remember which one is deep here. So now, from this figure we know the V is deeper, yes? So then this line is deeper. So this line is the constant volume line. Okay? I think it is kind of simple for you now.
Yes.
Okay, let's go to the third topic, thermodynamic process. As thermal process, we also call it constant temperature. Now we know the T is constant, or because PV is equal to RT, and also PV is equal to constant. And this is the process equation. Oh, so we can get the relationship. We can now here. This is the relationship between the PV. Okay, and because the calculation of Q and WT, it is a bit complicated. So we firstly talk about how to draw the figure. On the PV figure, it is not hard for us to draw the isothermal process line, yes? Because we know P is equal to here. Yeah? So it is not hard for us to draw such kind of lines. And on the TS figure, it is simple, yes? Because the temperature, we are not check the constant temperature, so it's like this one. I think it's quite simple for you, okay? Now, next, let's try to calculate the W. The W, you found just Notice here, the T, this T, it means the temperature, not the technique. Okay, so this WT is the expansion work, not the technical work. Okay, because here is a big T, and now we can calculate like this one. I think if you are good at mathematics, you can try to prove it.
Yeah,
It is quite interesting. It is really okay. It is really quite interesting. You just try to calculate it, okay? But for me, I don't want to spare a lot of time here. Okay. Here, this is the technique work.
Yeah.
We can calculate it also. Do you find any interest in finding here? Do you find the WT? Find this one? WT is here.
Yeah, it is the minus of the shaft work when temperature is constant.
Not the shaft work.
WT is what?
Here, this one is the technical work.
The technical work. Yeah.
This is the expansion work.
Expansion work.
Expansion.
Wow.
Maybe expansion is right. Maybe it's right. I think.
Yeah, it's right.
It's right. Okay. Expansion. This is the technical work. Okay. So you should remember for a constant temperature process, the worker do the expansion worker is equal to the technical worker. For the system do to the surrounding, okay?
Yeah.
If we use the figure to explain it, we should know the area 1, 2, 3, 4, 1 is must be equal to the area 1, 2, 5, 6, 1. Yes? Because for this area means the expansion work. For this area, it means the technical work. Yeah? Okay, try to use figures. Okay. And then if we try, then we can use some equations to calculate the Q. Here, the data H is simple. Data U is simple also. We know it is also all equal to 0. The ds is, we can also calculate by this equation. dt, data Q is equal to 0 also. So, do you find any problems? No. As we know, the definition of the C. What is the definition of the C? For a system, if there is a unit mass, and there is a temperature increase 1 degree, yes? The heat for the system needs to be absorbed. Is equal to C, yes? This is the definition of C, a specific heat. Yeah? For a constant temperature process, the temperature cannot be increased. Yes? The temperature will not change. So we have found no matter how much heat the system absorbs, its temperature will not change.
Yeah.
So this means this CV maybe is equal to a larger one. Yes? Maybe we can say CV or CP is equal to like this one. Yes? So this is a big value, and here is a value equal to maybe 0. So this maybe not equal to 0. The same, maybe we can say the CV is meaningless here, yes?
Yeah.
CV is meaningless and the CP is meaningless also. So we can conclude. Do you think this equation is right here? This equation, and this equation, I don't think they are right. Okay. When I say, I think they are wrong. Because here is maybe a value like this one. Yes? A big value times a small value, they may be not equal to 0. Do you agree with it? Yeah. So, I think this equation are wrong here.
Yeah.
So, maybe you say you want to know how can we calculate the data H, the data U. Do you remember H is a function of T?
Yeah.
Okay? H is a function of T.
Yeah.
So because the T will not change, it's a constant temperature. And hence H is equal to 0. So we can use this one to calculate the H. The same for the U. U is a function of T, it's an earlier function of T, because the T did not change. The du, not C, not H is equal to 0, but it's a data H, okay? It's data H is equal to 0. This one is data U is equal to 0. Yeah. For this one, this equation cannot be used here, but we can use another equation. Okay. Here. Try to use this one. We have found delta Q is equal to the delta W.
Yeah.
Yeah?
Q.
Because du is equal to 0. P dv is equal to delta W.
Delta W.
Also, we can use another equation, data. Maybe we did not write here. We can try. Here we can use data Q is equal to dH plus delta WT. Hence, delta Q is equal to delta WT. Yes? Here. Q is equal to W and equal to WT. It's also equal to this one. Yes?